In this video, we're gonna try to solve some first order differential equation using the separation of variables. Now, a differential equation is said to be separable if this can be expressed in this form: dy over dx is equal to some function f of x times some function g of y, where this can also be rewritten and rearranged to this form, where all the terms and expression containing y are separated from all the terms and expression containing x. Now, let's try to solve a problem here. We have dx plus e to the 8x dy is equal to 0. Now, the main idea of separation of variables is that we'll have to separate the variables y and the variable x. Say, let's subtract dx to both sides of the equation so that we'll have our dx on the right hand side of our equation, and we can cancel this, and we're left with e to the 8x dy is equal to negative dx. Now, as you can notice here, the function e to the 8x is in the left hand side where our dy is located. So we'll have to transfer this on the right hand side by multiplying 1 over e to the 8x. And then we'll have dy is equal to negative dx over e to the 8x. Now, after rearranging this differential equation into this form, we'll have to integrate this. We'll have to integrate both sides so that we'll have the integral of dy is just y is equal to, and moving out the negative sign, moving this out from our integral, we have dx e to the negative 8x dx. And we'll let u is equal to e to the, negative 8x. And then let's try to take the derivative. Du is equal to negative 8 dx. Multiplying by negative 1 over 8, we have our dx as negative 1/8 du. Now all our x will replace that with u. Y is equal to negative integral of our negative 8x is just u, so we'll have e to the u here, and our dx is just this, negative 1/8 du. And we can move the negative 1/8 out of the integral, so we'll have 1/8 here, integral of e to the u du. So we have 1/8 e to the u plus c, but our u is just this, negative 8x. So we have 1/8 e to the negative 8x plus c. Now this is our solution here. Let's try another problem. This one. And our first step is to separate the variables y from the variable x. So we'll add y minus 2 here, y minus 2 dx, and here also we'll add y minus 2 squared dx. So we now have, we can cancel this out here, and we have dy here is equal to this y minus 2 squared dx. Now to separate the variables, we'll have to multiply 1 over y minus 2 squared. That's why we have dy over y minus 2 squared is equal to, cancel this out, so we're left with dx, and then taking the integral, and now we'll let our u is equal to y minus 2. Taking the derivative, we have du is equal to dy. So we'll change all the y here with u, and we have dy is just du, so we have du here over our y minus 2 is just this u, so we have u squared here is equal to integral of dx. Then taking the integral of du over u squared is just u to the negative 2 du, and we have the integral of u to the negative 2 du is just 1 over negative 2 plus 1 u to the negative 2 plus 1. We just add 1 to our exponent and have our denominator also as this, as like the exponent. And we have, and then we'll change u back to, y minus 2. We have negative, so 1 over negative 2 plus 1 is just, so this is negative 1, so we'll have negative 1 here as a whole, negative 1. So we have negative u to the negative 1 is equal to negative y minus 2, since we'll change the u with this here, to the -1 is equal to x plus c. And then this equals to -1 over y minus 2 is equal to x plus c. Now, we'll try to write the equation in terms of x. Let's find our y in terms of x. So, we can move x plus c here, and our y plus y minus 2 here, and then adding 2 to both sides of the equation, we have our solution y is equal to 2 minus 1 over x plus c. Now this is our solution.